everyone, and today I'm going to talk about a paper named Large Language Models for Scientific Discovery in Molecular Property Prediction. So let's start by...
Sorry, miss. Can you go back? Yeah, it's your website. Photo, yeah.
So let's start by reading the abstract. So are you guys done with reading the abstract? So what do you think is the gap sentence here? So I think it's this one, because it states that there is still LLMs are not really explored in the field of scientific discovery. So what do you think about the abstract? Is there anything new or whatever? For me personally, because they mention examples a lot, so it was kind of new. Because whenever they explain something, they explain it with an example. So as we see that over the last century, scientific discovery have grown increasingly complex and resource intensive. Although the number of researchers are increasing with the resources, but still the research productivity has been decreasing a lot. So the reason for this is that today's scientific challenges have become more interdisciplinary and more abstract and data intensive. So for that purpose, the traditional scientific methods are increasingly struggling to keep up with the data complexity and we know that the scientific discovery relies heavily on two key abilities that are understanding the prior knowledge and reasoning abilities. So nowadays AI is beginning to play a transformative role. So recently in the field of AI, especially LLMs, they have both these capabilities, like they can understand from the prior knowledge, and they have the reasoning abilities to draw new patterns from the data. So the question is, can we use LLMs to accelerate the scientific discovery? So for that purpose, recently we are using LLMs a lot, we just prompt the LLM to generate a scientific hypothesis, or LLMs are trained just for direct prediction. So in this work, authors didn't want to do this. Instead, they wanted LLM for scientific discovery to imitate how human experts conduct the scientific research. So for that framework, this is their pipeline, that they use the knowledge synthesis from the scientific literature, and they also use the knowledge inferences from the data, and then using both information from these methods, they train the model, and after that they produce the insights that are interpretable.
So, do you get this? The key point in the below box. Is this what you are doing every day? please compare with what you are doing for your research about it. Is it what you do or not? Yeah, you get the knowledge from the published work, and then from either experiment or simulation data, you think, correct? Is there any other job you are doing except for these two? Then is it covered well? Yes.
So for the first step, the authors use the already pre-trained LLMs, and they use the vast knowledge of LLMs to extract the relevant features from the already done scientific literatures. So, for example, if a chemist wants to predict whether the molecule can cross the blood-brain barrier or not, so what they can do is, like, they can prompt the LLMs, and the prompting is really important here because they are asking the LLM to act as a chemist instead of just saying them to come up with the 20 or 30 rules. So when they prompt the LLMs with this kind of prompt, it extracts all the blood-brain barrier related prior knowledge, and it come up with these kind of rules. So after doing this, the next step is like, can they infer the knowledge directly from the data? So for that purpose, they use the LLM's inferential and analytical abilities to basically to identify the patterns from the scientific data. So what they did is they provided the LLMs with different data sets. For example, here it is a data set that contains the SMILE, that is the text form of the structure of the molecule. So the data is already labeled whether the molecule is the blood-brain barrier permeable or not, and then they ask the LLMs to try to predict the information from this. So how it works is that using the whole data set, it will try to compare all the molecules information and will try to find the patterns that match and that help in labeling whether the molecule is blood-brain barrier permeable or not.
Can you explain one more time?
So basically is that they just provided the LLM with the data.
You can
The data, it is just an example with the data set, and for that purpose, basically, for this example, they wanted to know, train or like tell the LLMs whether the molecule is blood-brain barrier permeable or not. So they provided them with the SMILE string, that is a text form of the molecular structure of the molecules. So, and they also provided the label data, which molecule is permeable and which is not.
There is okay. Then.
So then they gave this data to the LLM, and they prompted them to extract the relationship between these molecules, like if they will compare the patterns when it is labeled 1 and when it is labeled 0. So they will try to extract the features that are most common in the permeable molecules, and they will, on the basis of that, they will try to come up with the rules. Like if the molecule contains...
What do you mean you didn't give all the data, you said? Rather than training the data?
No, it is like there are different kinds of data sets for the molecules. So they provided the LLMs with that data, and on...
So in one sentence summaries, rather than predicting something, just inferring the rule.
Yes. So it is more like it will comparing basically the structure of the text, and will try to check for the patterns that are consistent for the permeable molecules.
Yeah, so my question is, there is one sentence you talk, rather than doing something they are trying to do. So in one sentence summary, it's just you give a data and then they ask you import the rule of the PV.
Yeah.
Am I correct?
Yes.
Okay.
So after that, they will be getting the combined rules from the prior knowledge and also from the inferred rule. So after that, they put this through the GPT and ask it to convert these rules into the executable Python functions, and they use RTKit package is to calculate the molecular weight of the molecule, and then according to the rules, they were assigned, if for example, if the molecular weight of the molecule that is entered in the data is less than 450 Daltons, then it is more probably to be the permeable molecule. So if they will assign a binary output will be 1. So it is kind of like they converted simplified rules into code, and then the output was binary so that they can easily convert into the vectors for the later use. So for each rule, they generated the code using the GPT, and they got something similar to this vector for each molecule. Then they entered this information and trained the random forest or the linear classifier to finally predict the molecule, whether it is permeable or not. So for the prediction, let's say we have a propanolol. So if a user wants to predict whether it is permeable or not, so the result will show that it is permeable, and it will also show how it came to that conclusion. It will checklist all the inferred rules that were explaining best that it is the permeable molecule, and also they also provide the rules and their importance, and it helps in identifying that which rule is important in predicting the outcome.
This importance is only for this example or everything?
But this importance is like it
For
will be
this
for-
specific molecule or every molecule?
No, if you want to predict any molecule, just enter the string of that and then smile string of that, and it will do everything, and it will give the insights in this form.
I don't understand what is the meaning of that arrow from that.
So basically it is like just referring to the rules and what is the importance of that specific rule. Like if let's say that rule number 4 is the most important in defining whether this molecule is permeable or not. So it will just tell the importance of the rule.
So you mean to determine if the molecule is permeable or not, the rule 4 is really important. But
Yeah. So like
yeah.
it will provide. It is like they will provide the insights, like which rule was important in predicting that this molecule is permeable or not.
So because that proprietary law doesn't have that rule, doesn't meet rule 4,
Mm.
so it could not be
Not
permeable.
permeable, yeah. Kind of like that. But this example is just for
Mhm.
example. So it is just the purpose of this is to just make it like tell how it came into that conclusion.
So simply saying, we are using LLM for feature extraction.
Yes.
LLM can use prior knowledge, and also it can find some patterns
Yeah.
in the data. So they combine both with these features. You do one more, some random for some method,
Yes.
and then you check the conclusion. Is that correct?
So basically for their framework, they just provide it at the end of how they came to this conclusion, to show that how it is working at the back end.
Oh, then that means that the framework we should or to hold these
Hold
things is unlikely.
Yes.
I think that in their code, they have prompts to generate the function,
yeah,
function.
So, yeah, there are two ways. They are actually launching their website too. So there are two options. They tell you that you can prompt something like this to the LLM and it will do this. Or otherwise it is kind of a bot. It will ask you what kind of thing you are going to predict. Then if it is classification, then it asks about the molecule or whatever information you have, then you enter it, and then they come up with all this. And actually the coding part, where they use GPT to generate the code, it can be like after generating that code, person could check and also edit the code if there is any problem or whatever. So after doing all these things, they have like performed total of
Go back.
50.
So,
Yeah.
can you go back? I think, yeah, why I feel uncomfortable about this presentation flow is it's unnatural to me. Because if you train something, what is the first thing you have to show?
To show the training data
Training and then
and the prediction.
performance.
Yeah.
What is performance of this?
It is later.
Later, yeah, so kind of that's why I feel uncomfortable. First, you have to show the performance, and then that rule where it is basically feature importance, right? So feature importance should come next. That's the typical machine learning algorithm presentation flow, right? Because if you don't show the accuracy of this algorithm, the feature importance doesn't matter, does it? Can you believe it? So what was the performance of this?
So it was almost 70, almost 80%. But it is different for every domain.
For this example,
No, there is nothing like that for this example. So basically, this is the framework, how it works. It just goes like this. According
and
to
then they
them.
didn't perform it.
Yes.
I see. This is just example.
Yeah.
Okay. Got it.
So after that, they tried to check the rules that were derived, whether they were significant. They divided it into 3 groups. Whether the rules that were synthesized were significant and they were supported by literature. And the second one was that whether the rules were statistically significant, but they were not found in the literature, they were novel. And the other one was like the rules that were statistically insignificant. So if we look here for the synthesized knowledge, we can see that almost every
So Aksa, we cannot understand. Can you go over everything?
this one.
Everything. We
So
don't know.
basically, like
From
this.
the top to
Oh,
bottom.
okay. So they tried to use 2 basic tasks from 4 different domains to check whether the rules are statistically significant or not. So for that purpose, these blue ones are the synthesized rules that were from the synthesized
So far,
model.
you talk about the blood BBBP, right?
Yeah.
So then you should begin from that part first, and then extend it. That's how you present. So which one you should go first?
Blood variant
Yeah.
variability.
Can you explain?
So for the synthesized knowledge, almost 90% of the rules were significant, and these 90% rules were also supported by the literature. And for the inferred knowledge, almost 75% of the rules were
What is the
literate.
synthesized?
Synthesized is from the literature. The first step that uses the extract the information from the.
I don't understand this graph. What is 90%, 10%? I don't know.
So basically, when they trained the model and everything, they had a set of rules.
Yes.
And the rules were from synthesized knowledge, that is basically from the literature on which the LLMs were trained.
Mhm.
And for the inferred one is the one that were derived from the data itself.
나만 이해가 안 돼. Is there anyone who understand that?
So I think the LLM makes so many list of rules
Yes.
that, but there are two tracks. One was just ask LLM based on prior knowledge,
Mm-hmm.
make rules. And second one is you plug in the data itself
Mm-hmm.
in there and say find patterns. So here synthesize means that the first one, the inferred one is the second.
So what we so far discussed is synthesized or inferred?
Also, the previous one they used both rules together and then finally predict whether it is UUP or not.
Together, right?
Yeah, together.
But what is the meaning of this separation, 90% or 75%?
So I think I need to ask. So what I want to say is that the synthesized means the one, that one, the inferred one, the second one. But we need to figure out what the percentage means.
So basically, this percentage is that the rules that were statistically significant in predicting the outcome. And for here, like the 90% of the rules were significant for predicting the outcome of the whether those rules were important in predicting the DBBP. And
So that's why I'm confused. Synthesized means, do we have still rules here?
Rules?
Inferred, yeah. Inferred has rules.
Yeah.
Both synthesized and inferred both have rules.
yes,
So could you go back to
Then I don't understand. What is the synthesized and inferred in this presentation?
So here, this
What is the synthesized and inferred here?
so synthesized
Please find it.
is
and the prior knowledge rules.
yeah, these are the prior knowledge group that is based on the literature.
That's a synthesized rule.
Yes.
And then,
The second one is
These are the inferred rules that are based on the data.
so then what's wrong here in this presentation? Synthesized rules. Have you used it? See? So everyone, when you make a presentation, you shouldn't make a new word. Aksa, you pretend that we know all the words synthesized rule. When you give that 90% thing. But have you explained it before? Yes. That. Then can you go back to the original slide and then can you explain that again, what is the synthesized and inferred?
So synthesized are the set of rules that are derived
No,
from
go back to the original slide where the synthesized appeared first time.
Oh.
Let's pretend that you give a talk, okay?
So these prior knowledge rules are actually the synthesized rules that are from these. These are the rules that are synthesized from the knowledge,
Synthesized knowledge using the
using the
LLM.
already available scientific literature and texts.
How do you get that?
So from the LLMs.
You plug in the basically papers, and then using the LLM, you get the rules. That's what we call synthesized
Synthesized rules.
rules. That should be the first key message in this slide. And the next slide, you plug in the now data to the LLM, and then they will generate the rules from the data. We will call that inferred rules. This should be the two key messages you should be very clear when you give this talk, and then move next. And then next, oh no, in this slide, what you have to do is, here, what is missing?
Synthesize.
Inferred rule, you say combine prior inferred rule, you keep saying that, right? No, right? What we have to do,
Synthesized and inferred.
yeah, synthesize rule plus
Inferred.
inferred rule to train the model. And then next, before the slide, and this slide is also very misleading. We shouldn't use this kind of arrow flow. Here we just need to show that feature importance. Because how you will define the 90% and 10% thing? Using this feature importance is statistically significant. How do you define the statistically certain rule is significant or not? How do you define? So to understand next box, we need that one. So everyone, is there anyone who know? Min, do you know? If we have XGBoost feature importance, or Mina, how do we determine that that feature importance is significant or not? Is there a way?
Depending on setting, it is different, but it evaluate how it increased the R2 score or
Can you go next slide? So how we define this 90% or 10%? This is statistically significant or not? There is two-sided Mann-Whitney U testing. How can we define it? Yeah, please find it. 로직 테스트 했더니 저 90% 치고 들어오지 않나?
So to check the distribution of the chosen role for the prediction across different so across the two target values, and then they check whether the
Let's see. I think the image is a very simple this thing. 네? 저거는 안 될 텐데. 인포가 안 나오는데. 룰 1이 significant 한지 아닌지 알고 싶은데. 그러면 분포가 나와야 되는데. 쉽지 않은데? 어떻게 하지? Do you know? Can you draw the distribution? What kind of distribution?
I don't know the distribution.
그냥 박스 플랫 그리고 두 개, 페이지 컨셉 하겠습니다. So I think they just, so if this is classification problem, there are two classes, right? As for each rules, they compare two distribution of that feature.
So does it mean 15% and 9% have the same distributions? And 86, so if you like look at the first one, it means 86% have different distributions, independent one, whereas the 14% have the same ones. Because that's what the two-sided Whitney test does.
But
So I think they didn't use feature importance.
yeah, I don't think so. It's impossible.
Yeah, so they just, if this is classification problem
Yeah.
for these two groups, for each rules, they have two distribution and
But what is that distribution? Because it should be just flat, isn't it? 0 or 1. That's why I'm confused.
so I think these features can be categorical or continuous variable.
So basically for the regression test, they explicitly mention that 0 if it deviates from 0.
Because if rule 1 is, but rule 1 is sometimes categorical, right?
Yeah, so
For the categorical, how can we get the distribution?
right, that's
So the first question is something is greater than 450, then either yes or no. Yeah. Guess I'm confused. Let me check. Yeah, let's study. You can do it. You know the paper name? Can you show the paper name?
그건 스태티스틱
카테고리가 아니면 그냥 그 두 개 그룹 사이 분포 구해서
네, 그냥
다른 문제는
패턴이 많이 보고
그렇지. 근데 카테고리가 이거 분포가 안 나오잖아.
그냥 컨티뉴스 테이블 그냥
그냥
컴퓨전 테이블
두개 나오는데 말이 안 되는데.
뭐 컴퓨전 테이블 그려가지고 여기 안 나오는 애들이 좀 교수가 저거가 그걸로 무슨 호흡을 명확하게 사고가 안 나가지고
레이블 시뮬라리티
이게 말이 안 돼. So no one has idea for categorical variable, right? I don't think we can use that stat test for the categorical variable. 안 되지 않나? In particular, yes or no면. 우리가 안 된다.
여럿이.
될 수도 있겠구나. yes, no로 해가지고. 뭐가 나오긴 나왔구나. 근데 우리도 yes, no니까 그냥 두 개.
그게 그 양쪽으로 퍼지는 그 대각선에 있는 거 이렇게
되긴 되지.
그런 거 빠질 수 있구나.
근데 거기다 이걸 해도 돼?
그게 제가 검색해 보면 하이스퀘어 테스트, 뭐 피셔 리젝 테스트 이런 거 나오기는 합니다.
Okay. For instance, rule one is, for instance, let's simplify it like a molecular. We ask us just continuous molecular length. That's rule one. Like a larger molecular length is group one. Let's say. Then what we'll do is there are two groups of the molecule. One has a level 1 or level 0, right? BUP or Bale. Then we will draw the actual molecular length. This. Then there is actual distribution, right? So if these two are really significantly really different, that means this rule one is really effective, significant. We say that. But now let's change the rule. Molecular length is greater than 400. Now yes or no question. Then rather than continuous value, we will have either yes or no. So either 1 or 0 value, right? And maybe a lot of them are here, small here, a lot of them are here, small here. And maybe we can also do the jump step test. These two are same or not. By doing that, I think we can test the significance. So in that sense, can you go to that box? Then here for the blood barrier permeability, the rule from the literature, 90% are effective. But LLM, the new rules observed by the LLM, 75% are effective. It's pretty. Actually, this blue should be actually good because this is published work. It's a common knowledge, but it's pretty comparable. It's new knowledge by the LLM, which never identified by the scientist.
So
It's wrong.
it is like the inferred knowledge, but it is also supported by the literature. Like it is already present in the literature, but it inferred it using just the data. And also this 25% is the new knowledge. that is not present in the literature. Because like even if it learns from data, it can get the information that is already in the literature.
Okay, gotcha. I see. So, okay, then, among the prior knowledge, this is from the literature,
Yes.
and then 10% is wrong, ineffective, although it's published work.
Yeah.
And then among the input, there's no grade, so everything is significant because it's working for the training the model, so it should be effective, I guess. And then, but among this, 75% are actually matching to the, I think maybe here,
Yes.
and then 25% is really
Yeah.
using.
Okay. My question is that, so when you test the significance, they divide train and test data?
Though they actually don't
Don't mention about it.
mention about data.
It'd be surprising if we separate train and test. We infer some rules from only train test, train set, and we test the significance with test set. And I think it's really surprising and good.
Yeah.
But I'm not that, but I think the authors didn't mention
Mention it.
Yeah.
Maybe, yeah. But if they didn't separate the training test, maybe
And that shouldn't,
they shouldn't happen, right?
Yeah.
So that's why I think they use the separate the train
Yeah.
and test test.
seems good.
Okay. So anyway, before moving to anyway, you will explain the other part, but this is for everyone. How to prepare the talk. So, oral teaching. This is very important. In this example, when you give a talk, Aksa, first thing you have to think about is what is the key message you want to show. That's the first thing. So far, what is the key message? From the beginning to until now, what is the key message? What we care? This, isn't it? This is key message. Agree or not? This is what we want to know, right? Okay? So, first step is determine the key message. So, this box. That's the first step. I want to explain this key message well. That is the goal of this genre club. Then next step is very easy. Now you have to go backward. Look at this box. To make these people understand this box. Now it's become very clear what I have to explain prior. Synthesized, invert, right? And then 90% this box color and this number. If after you decide a key message, now you have to look at what I have to explain prior to explain this key message. To make you understand this thing, just reading. Number one, what is the BBP? 1. Number one. Number two, synthesize, invert. 3 so far. And then colors. They explain here, right? So 3 colors, 1, 2, 6, and then number, how we get this number, 7. This 7 should be prior 7 slide. that's how we make the slide effectively. But other person work in opposite way. They just begin from the paper introduction. And then story is messed up. Always from the back to the prior. End of your slide to the prior. Because your end is determined. After you determine the end, and then think about how should be your prior slide. Make sense? Next time, if you make the key message, before it, thinking of write down what you have to explain. And this will be your previous slide. Actually, it's the same for writing as well, right? When you write the paragraph, how you do it? That's the sentence first, and then thinking about what should be the build-up. And then it should be same for your teaching as well. Let's say I want to teach this quadratic formula. You make a decision, right? This is key message. And what I have to teach first, to understand this formula, what students should know? A, B, C, and square root, plus minus. Then your prior slide should be about what is A, B, C, and square root, and plus minus. Because some students don't know what is plus minus mean. Some students don't know what is square root. Does it make sense? So that's why it's very difficult to prepare the slide, because you have to think in a reverse way of naturally you think the correct way. Everyone prepared the slide from the slide 1, 2, 3, 4, 5, 6, right? But that's wrong. You make a final slide first, and then build it. Does it make sense? Clear? So then you reach to this slide. So then, furthermore, you shouldn't show everything here. It's too much. What do you have to do first? Just copy this. You have to explain very detailed about this box. And then next thing now, next slide become much more easily understandable, right? Make sense? Okay, then now we are here. Then can you go over other things?
So basically, the other two tasks, they had, instead of the knowledge that was already in the literature for the synthesized rules, they found some of the rules that were not in the literature. Or reported, they were not reported in the literature before for these two
What is
tasks. So these are two tasks that they.
Can you tell which part you are talking about?
So basically, overall, if we look here, so most of the synthesized rules are the ones that are significant and already reported in the literature. But for the toxicity and the inhibition of waste, they found some rules that were already not explicitly reported in the literature, and they were new rules, but they were still in the synthesized knowledge.
Oh, so I see. The green, light blue is unknown rules. LLM find just by studying the literature. Okay.
So from here, they concluded that even without using the or analyzing the data, the LLMs can tend to summarize or come up with the rules based on the literature before. So then they checked whether if just using the synthesized rules are important in predicting the outcome, or just using the inferred rule, or just by combining the both synthesized and inferred rule. So they got that in almost every case, by combining the both kind of rules, gave them the better results than just using individual rules from either from synthesized or the inference.
So Aksel, okay, so let's practice this. One thing you have to fix is you tell the interpretation of the result first, meaning of the result first. But before that, what you have to do is you first explain what that figure first. So simple example is, because some people do I know. Ice cream. So temperature, ice cream sales. When we have this kind of graph, as temperature goes up, ice cream sales goes up. I know, we can do it. But the more kind explanation is, x-axis is temperature, y-axis ice cream sales, and here is correlation graph. Because they are highly positively correlated, so that as temperature goes up, ice cream goes up. So explain what the graph first, and then meaning. So when we saw this kind of graph, we are very confused. What is this 3? What is this number? We don't know. So can you explain first, using this example?
So for the physiological synthesis,
Mm-hmm.
they wanted to check whether the synthesized rules are important in predicting the outcome, or just the inference rules, or if we combine both synthesis rule and the inference rule, whether they help us in improving the prediction more. So for that purpose, they use the ROC test, and they found out that
Still, you didn't explain the graph yet. Let me do. Here, the number is prediction AUC ROC. So higher means more accurate. Here is only when inference rule is used. Here is when only synthesis rule is used. And here is both are used. I didn't give any interpretation, I just give information of what this means. No bias. Okay? You should give a chance to people think what that graph is. And then you should give a chance. Oh, both is important. Before you tell the conclusion. Do you know what you mean? And if you tell the conclusion immediately, that means you remove the chance that people can get the thrill by finding some key point. You watch the movie, right? What if you show the final movie to the first scenery? Do you like that movie? 범인을 먼저 알려주면 좋은가? Okay, so there's nothing. So here, just tell what is x-axis, y-axis, and number means that's all first thing. And giving some seconds, and then tell the conclusion. Can you do one more time?
so this is the prediction AUC graph. Here, the numbers are like, if the number increase, it is good, the
Mhm.
performance is good.
Mhm.
And here we have the rules that are from inferred knowledge,
Mhm.
and then we have the rules that are from synthesis, and then we have both rules from synthesis and inference.
So, and then now, at this point, you already knew that what she may tell, right? Then audience become very, what they feel is, wow, she's giving a good talk. Because you understand the key message by yourself. What is a good teacher? Before teacher give you the exact answer, if a student can serve it, don't we call that the best teacher? Yes. You should give a chance to student to come up with by themselves with that key message. But if I do what you did, and here's a graph, using the both is better than synthesis and inference rule. Did they have a chance to think about the key message? Okay, you should help them. Okay, so as you can see for physiology variable, both is better. And then if you explain this, then other things become easier. That's another rule. Don't try to explain 14 first. If I were you, I remove this 3 figure. I will show this first. Just focusing on. And then animation, animation, animation. But now you already recognize something. You should explain it. There it is.
For the physical chemistry,
Uh-huh.
they tried to check the MSC, and the lower rate of MSC is better in predicting the results. So for synthesis,
So here is a lower is better.
yes.
So yeah, don't be confused. Here is not the AUC, IOC, right? Then you should explain before you again tell the conclusion, right? Please explain that. What is that number first?
So here we have basically for RMSC, if the value is lower, it is better,
Mm-hmm.
and we want to have the lower rate of RMSC. So for the if you look here,
Here, then what is the best? Using the game?
so it is like using the both
Both is
is
best.
best,
And
and
second is inference.
Inference.
And third is
third is the synthesis.
yes. And then what is that MAE? We don't know.
MA is also similar to the RMSC. The lower the value, the better.
Mm-hmm.
So for this case,
Mm-hmm.
again, the both is better as it has the lowest
Mm-hmm.
MAE, but in this case, the synthesis is better than inference for quantum mechanics.
Yeah, that means this is quite interesting point, right? Physical chemistry, inference is better,
Yeah.
the data driven. But quantum mechanics, literature is better.
Because I think it is most like probabilistic kind of thing, so that's why the literature is better than
Mhm.
just getting from the data.
So is there any idea why do you think that quantum and physical chemistry could be different? Any idea? So physical chemistry means like maybe their binding rate, something like that. What is the quantum mechanics? I don't know. Yeah, it should be more challenging job. What do you think? Do you think that makes sense? Why quantum literature driven is better than data driven?
Maybe within quantum mechanics, as I said, you cannot obtain
Good.
the data, because
Yeah.
once we measure something, then it collapses to some other state.
So yeah, that's a very good point. So actually, one interpretation from this is, so physical chemistry is like a 100-year-old history. That means we have a pretty good experimental technique to get the good quality of data. That's why data-driven rule could be effective. But as you know, quantum still our technique is not enough to get a good quality of data. So the genius brain describing that quantum dynamics seems better than data driven. So this is a pretty interesting graph. Actually, if we do, actually, I know this is for the scientific finding, but this could be used to describe the characteristic of certain field. If a certain field has this kind of graph, what that means? Our experimental skill is more than enough to get a good data. But this one, we are in the pre-theory, let's go back to the 100 years ago, when Einstein made his black hole theory, relative theory first time. I'm very sure this isn't. There was no data from the black hole. But nowadays, maybe we move to here. So this is a very interesting approach. We can diagonalize a certain field. Okay.
So the last one is that LLMs greatly rely on what backbone is used. Like there are different kinds of LLMs. There are basically two domains in which one is general and the second is domain specific. So for general, it is just trained on all kinds of information, and for
So let's practice again. We have a graph. Rather than tell any other thing, just tell what is x-axis, y-axis, and triangle mean. That's what you have to do first.
so x-axis is different kinds of LLMs frameworks that are used nowadays, and the y-axis is their prediction accuracy, like how well they are predicting. So for the field of physiology, if we look here, actually it is not mentioned here, but
GPT-4.
GPT-4 and Falcon 40B and 7B are general GPTs, like they are trained on general information, while these four are domain specific, and there is a difference between these two. This one is pre-trained from scratch, but these two are fine-tuned from existing general GPT or general LLM. So fine-tuning means that they just take the general LLM and they just provide it a small set of data from a domain-specific knowledge, and they just train it on that data to make it more specific to a specific domain.
Row 5 video, same conclusion.
So for this one,
My
if we
side,
look,
yeah.
GPT is like performing a
Yes.
lot better. And then if we look here, we can say that Galactica 30 and 6.7 million is also kind of close to the GPT-4's performance. So, but in case we see the other models, they are kind of performing lower than these models. There can be different kinds of reasons behind this thing. First is that if we look at GPT-4, it is really extensive and it is trained over 143 billion tokens. So it has a lot more knowledge. And for the Galactica, It is, there are two sizes. This one is like 6.5, it has 6.7 billion parameters, and this one is 30 billion parameters. Although the sizes are different, but as they are domain specific, so their knowledge, if and we can say that if an LLM is domain specific, then it can perform better in predicting the outcome. This, although like if we look at the Falcon 40B, it has 40 billion parameters, but it is failing because it is trained on the general data.
So, yeah, okay. Because it's your first presentation, let me give you one more feedback. Yeah, everyone, do you understand or not? Well, you should be frank. How many people understand what she wants to tell? Do you know why? I think I counted how many sentences you tell. It was 20. 20 from this part. No one can follow the 20 sentences. If I tell the 20 sentences, Galactica is blah, Galactica is blah, camera blah, 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 blah. Can you make it? No. So if you think that is really important, what do you have to do?
But
Yes, you remove every other things. If you think that's really important to spend 20 sentences, animation, animation, animation. If you think that's important, if not, you don't have to tell. What do you think? Yeah. So what's the key message here? You don't care about what failed. What is best? GPT-4 and Galactica, right? These two are best. And what people want to know, why they are best, right? Why? Can you tell?
Galactica is basically trained on the domain specific data,
Mm-hmm,
so that's why it is performing better.
mm-hmm,
And for ChatGPT,
mm-hmm.
it is trained on extensive data, like more than 100 times of the existing LLMs.
Mm-hmm.
So that's why ChatGPT, GPT-4 is performing.
So now let's go back to here. Again, this property. So when you want to explain this, you have to think about the key message first. I want to tell just two things. These two are best. And then I want to explain why they are better. That's the key message. And then think about to make a slide. This, they're best because they are based on much more large data set. And these are based on domain knowledge. Done. Make sense? Okay, can we go over this next? Same?
Yeah, it's the same for the biophysics too, but we can see a bit of a gap between Galactica and GPT.
Mm. Okay, so GPT is best.
Yes.
Okay.
So for the physical chemistry, it is the opposite. The lower the value, the better it is. So in this case, also Galactica and GPT are performing kind of parallel. And for the quantum mechanics too, it's the same. That's all.
Somewhere? Oh, I see.
That
Okay.